first three parts of this presentation, a complete air brake system for a straight truck or bus was explained. In this, the fourth and final presentation, we'll add the components to a straight truck which are necessary to tow an air brake trailer. Then we'll look at the trailer air brake system itself. Let's begin. In order to tow a trailer, a truck must be able to charge it with air and transmit brake signals to it. Two air hoses extend between the tractor and the trailer to fulfill this function. They are called the trailer supply and trailer service lines. The opening and closing of these two lines during normal and emergency operation is controlled by the tractor protection system, which is composed of two valves. There are a number of different valves that can be used. In this program, we'll look at the most basic and popular, the TP3 tractor protection valve, and a control called the PP7 trailer supply valve. Mounted at the rear of the cab, the TP3 tractor protection valve functions as an on-off control for the service line, which carries brake applications from the tractor to the trailer. The TP3 is a simple valve internally and consists of a body, the plunger with its integral service valve, and a spring. There are four air connections on the TP3, the tractor supply and tractor service ports on one side, and trailer supply and trailer service ports on the opposite side of the body. Each is identified with cast-in lettering. Air exerts a force on the plunger as it flows through the TP3 from the tractor supply to the trailer supply port on its way to the trailer air system. When air pressure on the plunger exceeds approximately 45 psi, the plunger moves, opening the service inlet valve. With the service valve open, brake application pressure is free to flow from the tractor to the trailer brake system. The other half of the team, the PP7 trailer supply valve, is mounted on the vehicle dash and is easily distinguished by its red octagonal control button. The PP7 controls the flow of supply air to the TP3 and subsequently to the trailer. In addition, it synchronizes the tractor protection system with the tractor parking system. One-button parking control is thus achieved. Like the PP1, the PP7 button must be pushed in manually, but will pop out and exhaust automatically if the air supply drops below approximately 40 psi. Supply pressure of 50 psi or greater assures that the button will remain in until manually pulled or supply pressure drops below 40 psi. The PP7 is a combination of two pressure-sensitive on-off control valves in one body. The upper portion is almost identical to the PP1 push-pull control we studied in Part 3 of this series, while the lower half contains an SV1 synchro valve. The upper half of the PP7 consists of a control button, plunger, spring, and inlet exhaust valve. The lower half contains a piston, piston return spring, inlet exhaust valve, and valve spring. In addition to an exhaust vent and exhaust port, the PP7 body has three air connections: supply port, delivery port, and control port. The supply port is connected to the same double check valve that supplies the PP1 park control. It is therefore assured a constant supply of air pressure regardless of a failure in one of the service reservoirs. The delivery of the PP7 is connected to the tractor supply port of the TP3, and the control port is connected to the delivery of the PP1 trailer release valve. With the vehicle parked and no air pressure in the system, the PP7 control button is out. The inlets of both valves inside the PP7 are closed, and the exhausts are open. When tractor system pressure builds to 50 psi or greater, the PP7 can be depressed and will remain in. With the plunger inlet open and the exhaust closed, air flows from the supply port to the closed synchro valve inlet. The synchro valve piston remains down due to a lack of air pressure at the control port. The PP7 delivery port remains open to exhaust. When the PP1 park control is depressed, air pressure simultaneously releases the tractor spring brakes and is delivered to the PP7 control port. Air pressure at the PP7 control port moves the synchro valve piston, sealing its exhaust passage and opening the inlet valve. Air from the push-pull section of the PP7 flows past the open synchro valve inlet and out the delivery port, then through the TP3 to charge the trailer reservoirs. If tractor air system pressure falls to approximately 40 psi during vehicle operation, the PP7 button will pop out. Air from the trailer's supply line is exhausted at the PP7. This preserves the last 40 psi of tractor air pressure and causes the trailer parking brakes to apply. Note that the synchro piston remains unaffected. If the PP7 button is held in and tractor air pressure has dropped to approximately 20 psi, the synchro piston automatically moves into the exhaust position. Although the driver continues to hold the button down, the trailer supply line is exhausted and trailer parking brakes are fully applied. During a trailer breakaway or a sudden complete trailer supply line failure, the PP7 button will pop out automatically. The tractor air system will retain between 40 psi and full system pressure depending upon the location and severity of the failure. Air escaping from the failed supply line cannot be replaced through the PP7 supply port as fast as it's lost. This causes pressure inside the PP7 to drop below the 40 psi pop-out pressure, even though supply port pressure is much higher. Because of the synchro valve section in the PP7, the tractor protection system is linked to the tractor parking brakes. To park a tractor-trailer combination, the PP1 park control is pulled out. Air is exhausted from the tractor spring brakes and from the PP7 control port. With no air pressure at the PP7 control port, the synchro valve piston moves, seating the inlet valve and opening the exhaust passage between the PP7 delivery and exhaust ports. Air from the trailer supply line returns to the PP7 and is exhausted, causing the trailer parking brakes to apply. Note that the PP7 button remains in. This is due to the PP7 synchro valve exhausting the trailer supply line. Pushing the PP1 park control in releases the tractor parking brakes and delivers air to the PP7 control port. This causes the synchro valve piston to close its exhaust and open the inlet. The trailer supply line is recharged and the trailer parking brakes release. To disconnect the tractor and trailer, the operator must pull the PP7 button. Pulling the button closes the plunger inlet and unseats the exhaust valve. Air that was flowing out the delivery port returns to the PP7 and exhausts from its vent. Test the tractor protection system by pulling the PP7 out and making and holding a brake application. Apply a soap solution to the trailer service and supply line hose couplings to see if the TP3 or PP7 is leaking. Our basic tractor system is almost complete, but before moving on, we must consider one additional device: the DS2 double check valve and stoplight switch. We learned in Part 2 that vehicles are equipped with dual brake systems, a protected braking circuit for the front axle brakes and a separate circuit for the rear. Since there is only one service line leading to the trailer, one or the other of the two braking circuits must be chosen to apply the trailer brakes. And, of course, the stoplights must be lighted regardless of which is chosen. That's the function of the DS2. It's a combination of two valves, the SL5 stoplight switch from Part 2 and the double check valve from Part 3. Like a standard double check valve, the DS2 has two inlet ports and one outlet port. The stoplight switch is positioned in the middle of the double check valve opposite the single outlet port. A shuttle riding in a guide travels between the two inlets. Lines from the front and rear axle brake circuits connect to the inlet ports on opposite sides of the DS2. The outlet is normally mounted to the tractor service port of the TP3 tractor protection valve. During normal operation, brake application air from both brake circuits enters the DS2 inlet ports. Since the rear axle brake circuit pressure is slightly higher, the shuttle will move to close the front circuit side, at the same time moving the stoplight piston to light the brake lights. Rear axle application air flows to the outlet port, then through the TP3 and on to apply the trailer brakes. If one brake circuit on the tractor loses air pressure, brake applications from the remaining circuit would still flow through the DS2 to apply the trailer brakes and light the stoplights. Before going on to the trailer brake system, there is one accessory that should be considered: the BP R1 bobtail proportioning relay valve. The BP R1 combines a relay valve with a proportioning valve. It was designed for use in tractor brake systems only and replaces the standard R12 service relay presented in Part 2. The BP R1 improves control and reduces stopping distances by proportioning brake applications to the lighter rear axle brakes during bobtail tractor operation. The BP R1 body contains a standard service brake relay valve, while the cover houses the proportioning valve. There are 4 delivery ports, 2 supply ports, 1 control port for the relay valve, and another for the proportioning valve. All air connections are identified with cast-in letters. With the exception of the additional proportioning valve control port, the BP R1 air connections are exactly the same as the R12 relay it replaces. This port is connected to the air line running between the PP7 trailer supply valve and TP3 tractor protection valve. During tractor-trailer operation, the PP7 delivers air pressure to the trailer and to the control port of the BP R1. So long as control port air pressure is present, the BP R1 functions as a standard service relay valve and delivers full braking pressure to the tractor's rear service chambers. When the PP7 trailer supply valve is pulled, the trailer supply line is exhausted. Pressure is removed from the BP R1 control port, signaling that the tractor is now in bobtail operation. With the weight of the trailer removed, the tractor rear brakes are overpowered. In bobtail operation, The front brakes are capable of doing more to stop the vehicle than the rear brakes. They can use a much higher application pressure than the rear brakes. When the driver makes an application strong enough to take advantage of the stopping power of the front brakes, the rears skid and vehicle stability is diminished. The BPR1 compensates for this by reducing application pressure to the rear brakes only and permits the driver to apply the foot valve in a normal manner. This takes full advantage of the front brakes without locking the rears. Vehicle stopping distances and stability are improved. Here's an important tip. Only vented dummy hose couplings can be used with the BPR1, and the vent must be open. With the addition of the BPR1, the basic tractor system is complete. Let's now turn our attention to the trailer and look at a schematic of the entire system. The two lines that carry air into the trailer supply and trailer service lines, are connected to their corresponding air lines from the tractor. A hose coupling, or glad hands, installed at the front or nose of the trailer connect these lines. The trailer reservoirs serve the same function as they do on the tractor. Two reservoirs are used because this trailer has two axles, and Safety Standard 121 requires a minimum reservoir volume for trailer service brakes. An R12 relay valve, identical in operation and function to the one described in Part 2, is attached to one of the two reservoirs. Its delivery lines are connected to the service side of 4 spring brakes, identical to those described in Part 3. The trailer service line connects to the control port of the R12 and carries brake signals from the tractor service brake system to the R12. The R12 assures the trailer service brakes apply in unison with the tractor service brakes. The trailer service line also connects to the SR5, the last valve to be considered on the trailer brake system. The SR5 protects trailer air pressure and automatically applies trailer spring brakes in the event of a breakaway or trailer supply line failure. In addition, it permits intentional and repeated spring brake applications and releases. But it also prevents automatic applications when trailer reservoir air is lost. An optional anti-compounding feature prevents simultaneous application of service and parking brakes. Like many of the valves we've presented, the SR5 incorporates several individual components in a single housing. A relay valve lies at the heart of the SR5 and is comprised of a control piston and inlet exhaust valve. Along with the relay, there are 4 single check valves, B, D, E, F, and pressure protection valve, C. A male stud is used to mount the SR5 to the reservoir. A line from the SR5 service reservoir port connects to the same reservoir. The trailer supply and service lines connect to SR5 ports with the same name. SR5 delivery ports connect to the emergency side of the spring brakes. Let's take a look at how the SR5 operates, beginning with no air pressure in the trailer. Air flows through the trailer supply line, enters the SR5 trailer supply port, and encounters the relay piston. The relay piston moves into contact with the inlet exhaust valve, sealing the piston exhaust passage. Piston travel continues and opens the inlet. At the same time, air flows through passage A, then check valve B, past the open inlet, and into the spring brake cavities, releasing the spring brakes. Concurrently, air pressure acts on pressure protection valve C. At approximately 85 psi, valve C opens, allowing air to flow past check valve D to charge the trailer reservoirs. The trailer brake system is now ready for operation. If air in the trailer supply line is removed for any reason, whether to park the vehicle using tractor dash controls or due to a tractor-trailer breakaway, the spring brakes will immediately apply. Without pressure at the SR5 trailer supply port, the control piston moves, closing the inlet and opening the exhaust. Air from the spring brakes flows through the passage in the control piston and the spring brakes apply. Check valves B and D, along with pressure protection valve C, close to protect air pressure in the reservoirs. If supply line pressure was exhausted due to a park application, the trailer spring brakes are easily released by actuating the dash controls in the tractor to recharge the supply line. The trailer service line carries the brake application air from the tractor to the trailer. That air flows to the service relay valve and SR5 trailer service port. A single check valve in the SR5 cover prevents simultaneous spring and service brake applications, which creates extra load on foundation brake components. If a trailer service application is held at the same instant a park application is made, air in the service line flows through the single check valve, out the trailer supply line, and exhausts through the PP7 in the tractor. Future compounding is prevented by the closed tractor protection valve. Let's look at what occurs when trailer reservoir pressure is lost. First, trailer service braking is no longer available, since the R12 depends on reservoir pressure to apply the brakes. Inside the SR5, pressure protection valve C will close at approximately 70 psi, retaining air pressure in the trailer supply line. The air trapped in the trailer supply line by the closed pressure protection valve will continue to hold the piston's inlet valve open, supplying air to the spring brakes. Automatic spring brake application is prevented. However, trailer supply line air can be used to apply and release the trailer's spring brakes repeatedly. Before we close, let's recap. In order to pull an air brake trailer, a truck requires a tractor protection system comprised of a PP7 trailer supply valve and TP3 tractor protection valve. A DS2 double check valve and stoplight switch selects the highest pressure from the two service brake circuits on the tractor to apply the trailer brakes. In addition, it lights the stoplights regardless of which circuit is selected. The BP-R1 bobtail brake proportioning relay is an accessory that replaces the standard relay valve and provides increased brake control during bobtail tractor operation. The trailer brake system is comprised of spring brakes for service and emergency braking, an R12 relay valve like the one used on the tractor for rapid application and release of trailer service brakes, reservoirs to store compressed air for service braking, and finally, the SR5 trailer spring brake valve to control parking and emergency applications. An enormous amount of information has been covered in this series. Should you have missed any part of this four-part presentation of a tractor and trailer air brake system, we urge you to take the time to review all four parts. One final note. While much was covered, other system combinations and optional components are available, so the system presented is not necessarily exactly like your own. We hope you have enjoyed the presentations and that you have gained a deeper understanding of an air brake system. we urge you to review the programs frequently to maintain the insight gained.